In Chapter 8, we graphed quadratics, and in the difference between Chapter 8 and Chapter 9 is that in Chapter 9, we're going to solve the quadratics. Means that we're going to find the values where it equals 0 or it equals a particular number. So just as a refresher about the definition, a quadratic is a nonlinear equation that can be written in the standard form ax squared plus bx plus c equals 0, where a isn't 0, because if a is 0, then you just have a line. One of the lessons that we did in Chapter 8, which was 8.5 high school, we actually kind of did a little bit of this, where we found where the parabola was on the x-axis, which were the zeros. So we're going to look at that style of parabolas today. But just as a review, let's practice with the negative b over 2a technique for finding the vertex. So we have this quadratic right here. We want to solve it, and it says to solve it by graphing. So there are lots of ways you can solve it. Chapter 9 is all about the different techniques. The way that we're going to do it for right now is using the x equals negative b over 2a technique. So we have a equals 1, b equals 2, and c equals negative 3. And I pulled that right off the formula right over here. 1, 2, and negative 3. So now I'm going to go into the formula. X equals negative 2 over 2 times 1. So that gives me negative 2 over 2, which equals negative 1. So the vertex is at negative 1 comma. I need to plug in negative 1. So I'm just going to talk through it because we did this a whole bunch in Chapter 8. Negative 1 squared is 1. That would be 1 plus negative 2, which is negative 1, minus 3 is negative 4. So when you're graphing a quadratic, you ignore the fact that it equals 0. We're just graphing it generally. Where would it be at all points? And then when we look at the graph, we're going to see where it's on the x-axis. So now I'm going to make my chart centered around negative 1, 4, negative 2, negative 3, 0, 1. So pause the video, fill in the table. You can use the symmetry idea if you want to shortcut your table as well. So I've got my chart, and I can see in the graph, or I'm sorry, in the table, that those are going to be the zeros. But it says to graph, so I have to. So let me sketch a quick graph. And I'll plot the points. You can pause the video and plot them as well. Now the last thing that we have to do is actually answer the question. It wanted to know what are the values for x. So we actually have to say that these would be the values of x. So we write x equals negative 3 and 1. So you can write negative 3 comma 1, you can write x equals negative 3 and x equals 1. It doesn't matter. Either way is fine. But those are the two values. That's the actual answer to the question, not the graph. Alright, now I'd like you to pause the video. Since we did a whole bunch of graphing in Chapter 8, I want you to graph this one, but remember you can't graph it until everything's on one side. So let's look at this. We have to move the 16 over to the left. So before you do anything, you have to make this say y equals x squared minus 8x plus 16. Now pause the video and graph. Now when you look at this parabola, it only has one intercept right here. And that's the point where x equals 4. Now I just want to point out, I kind of shifted the origin. Oh, I'm missing my arrow tip here. I shifted the origin a little because I didn't need negative numbers because I saw in my table everything was positive. So I really just needed the first quadrant. So I just graphed it over in the positive section so it was more centered in the middle of the grid. But this only has one answer where x equals 4. Alright, this is another one to do on your own, but remember everything has to be on the same side. Now instead of bringing everything over to the left and keeping that leading coefficient negative, I'm going to choose to bring the x squared over to the right, and then the leading coefficient is positive because it's much easier to graph with a positive leading coefficient. So if I move the x squared over to the right, my equation would be y equals x squared plus 4x plus 5. All right, pause the video and graph that on your own. When you look at this quadratic, it actually has no intercept. It doesn't cross the x-axis at all, right? Because here's the x-axis and my graph is above it. So what we write in this case is no real solutions, meaning that there's no value where it crosses the x-axis in the real number system. When you get to Algebra 2, you're going to talk about imaginary numbers, and there actually are imaginary answers to this. There are two imaginary roots in the imaginary number system, but for the real number system, there's no place where it hits the x-axis. All right, the last thing to look at down here is the difference in the quadratics that we saw. When the vertex was underneath the x-axis down here in the negative area, we had it hit in two spots. That was our very first example. When we had it hitting on the x-axis, it only hit once. And when the quadratic had its vertex above the x-axis, then it had no real answer. There were no values that made the equation true. Down here in this bottom section, I want to just point out some vocabulary. There are a lot of words that mean the same thing. So we've got solutions, we've got roots, we've got x-intercepts and zeros. Those are all words that we've used before that represent the same thing, and what it means is where is the graph crossing on the y, on the x-axis, right? These values right here. All right, if you have any questions, write them down and ask me when you come to class.